Mike, as you obviously know, since you're the one that gave the presentations, we did a series here with you on the pre-flood flood boundary and the post-flood boundary.
Yeah.
And both those programs received a lot of excellent feedback. I've gone through those presentations thoroughly many, many times, and I know many of in our audience have as well. And so I'll start with a couple of the questions that I sent you. Now, I know this topic of flood boundaries is controversial in the creation world, but it's an important topic.
Yes.
And so the first question, and I'll lay out the context for it. So basically, those that would hold to a lower flood boundary rather than a higher flood boundary, like the late Cenozoic boundary model, they would argue that there is a significant decline. And they argue this in support of the lower flood boundary model. They'll argue that there's a significant decline basically in the amount of catastrophism taking place as you move up in the geologic column. And so the higher you get up into the Cenozoic, it seems less and less of the material is being formed from large scale catastrophe and more towards small scale ones. And the intensity of events are gradually being dialed down as you move higher and higher up into the Cenozoic, especially in terms of North America. What are your overall thoughts on these points, Mike?
Well, right off the top of my head, I would say that's what we expect at the end of the flood also, that it's going to be dialed down. So the deposition is going to be over smaller areas, so you expect smaller formations. But I might add that a lot of these Cenozoic formations are not that small. The Fort Union Formation, where I live, in Montana east of the Divide, adjacent Wyoming, South and North Dakota, is probably hundreds of square kilometers in area. And it's an erosional remnant. There was a lot of material on top of this. There's a paper coming out in the CRSQ where we can show 1,000 to maybe 2,000 meters of erosion in the Great Falls, Montana area. And the Fort Union Formation is about the lowest formation around. So I actually have a lot to say on that, but I have a few slides I want to show on this catastrophism that's supposed to be so violent at the start and then tailing off. It's actually violent at the start. This is from John Reed, new information. We haven't published it yet. The continental crust of the Earth is full of cracks, huge cracks called rifts. Here's the most famous is the Mid-Continental Rift. It's about, we should have a scale on that. It's about 2,000 kilometers long. It forms a horseshoe shaped like this. And it's about 50 miles wide. And here's some of the depths. You can't see these very well, but this blue area is 80,000 feet carved on top of the upper crust, deep. Monstrous crack. Then you have these basins like the Williston Basin, very circular, and the Michigan Basin, which I think are impact craters, which shows up pretty well on another slide that John Reed did. And there's other basins. So the continental crust, which I believe represents early flood, the rifts and the meteorite impacts. Now, some secular scientists have leaned towards it. These are meteorite impacts, but guess what? They get shot down. But it has many of the signatures of an impact crater that's filled in rapidly with sediments. So that's catastrophism at the beginning. So I totally agree that we had catastrophism at the beginning, but we had to have a lull in the middle. Why? Because when you look at the Grand Canyon, the sediments of the Paleozoic, you're seeing the Paleozoic here, 4,000 feet, they're evenly deposited with little faulting showing up. And then to the north, you have the Grand Staircase. See, this represents an erosion of maybe 8 to 12,000 feet, depending on how thin the layers were above, of strata. All over the Grand Canyon area was taken off as a sheet, leaving the grand staircase to the north. And these sedimentary rocks are pretty evenly bedded too. And this is mostly Mesozoic. So the Paleozoic and Mesozoic, including the Grand Canyon, the grand staircase, you have about 14,000 feet of strata deposited with little or no deformation, indicating, and I don't think this is a rare situation, indicating slow deposition. I mean, little vertical tectonics. So you had to have a lull to form this sediment pattern. And then in the early Cenozoic, you have an increase in catastrophism where practically all the mountains of the earth rose during the Cenozoic, including the mid and late Cenozoic, I might add. Sometimes 40,000 feet in the western Rocky Mountains, or the Rocky Mountains where I live here, starting in the early Cenozoic. So that's powerful catastrophism. I think that's what drained the floodwaters, was that catastrophism. And then you eroded 1,900 meters of the top of these sediments. Here's a block diagram. It's a schematic illustrating the current continental sedimentary rocks. We don't know the depth. We've been calculating, John Reed's been calculating them on North America. We're getting numbers about 1,500 meters average left down to the bedrock, mostly the upper crust, granite upper crust. And then 1,900 meters of the top was eroded off. So at the peak of the flood, you had 3,500 meters of sediment. And that got eroded off. Now that's pretty powerful catastrophism. So the upshot of what you see in geology is tremendous catastrophism at the beginning of the flood. And this formed the Great Unconformity at the same time, I might add. It takes time to form the Great Unconformity. Some people think that that's the precise boundary at the beginning of the flood, but no, that takes time to erode down maybe several miles to that generally flat erosion surface that you see in Grand Canyon, you see in my area, you see in the continental, the shield of North America. So it takes time for that. So I definitely don't think the beginning of the flood, pre-flood boundaries at the Cambrian, Precambrian, at the Great Unconformity. It takes time to form the Great Unconformity. So after things settle down, you start depositing all those sediments without much vertical tectonics and catastrophism until towards the end. When the mountains rose, the valley sank down. And that all happened in the Cenozoic. So it was a two-part catastrophism, and geology shows that very well. In fact, John Reed had a plot he published 15 years ago on the energy of the flood, which is proportional to catastrophism. He had high energy at the beginning, lower energy towards the middle, and then higher energy again towards the end. So that's what I believe answers the second question, which and some of that erosion, let's see, was this going to be into the second question? I'm thinking. Yeah.
Yes.
No, this is an example of some of the erosion that I did a trigonometry calculation over the San Rafael Swell, the northwest Colorado Plateau, where I got an average of 4,200 to 5,000 meters of erosion right near the top of the San Rafael Swell, based on trigonometry from this pass right here to about Helper or Price, Utah. 25 kilometers base. These tilt down to the north about 8 degrees. So by trigonometry, that's what I arrive at. And even to the north, there's about 2,000 feet of erosion in here. And I might add, you notice the top formation is a Green River Formation. This is considered a result of deposition of a post-flood lake by some creation scientists, but I find obvious evidence that that is not the case. It has enough oil to supply the energy needs of the United States for 100 years. It has tropical fossils like palms and crocodiles as fossils in it. And this straddles the Continental Divide in Wyoming. So it's an inland area, continental climate, high altitude. So we wouldn't expect post-flood palms and crocodiles. And besides, it's very thick. And if this is all post-flood, you have to think of this area forming the lake, depositing several thousand feet of the Green River Formation, bowing up the San Rafael Swell, eroding this whole area, part of the Colorado Plateau erosion, and eroding that much. And the material is not found nearby, but is totally swept off the continent. To me, and this might step on the toes of some creation scientists, to me, there's obvious big picture evidence that the Green River Formation is from the flood. Now, exactly how it formed, that's a whole different research project. So I can't tell you more because it's a difficult feature to figure out. But the big picture indicates it's from the post-flood. Let's see. Now, how was I going to relate? Oh, that's just part of that catastrophism late in the flood. This is just an example of the erosion late in the flood. Anyway, the second question, you want to get into that?
Yes. And before I do, firstly, great answer. You said some of the mountains arose 40,000 feet during the Cenozoic?
Yeah.
Wow.
For instance, I can show this in the Uinta Mountains. I did a 2-part article that was published maybe 15 years ago in the Creation Research Society Quarterly. And the Wasatch Formation was deposited first. That's early Cenozoic. Over the top of these other Mesozoic, Paleozoic. There's a general sequence of the geological column in the Western Mountains, I might add. General. And the uplift did not start until the early Cenozoic Wasatch was formed, and then it rose 40,000 feet in the Uinta Mountains and sank. It rose up to 14,000 feet above sea level and then sank something like 25,000 feet below sea level in the Uinta Basin to the south. So that represents a change of 40,000 feet for the Uinta Mountains. And you can show this in other mountain ranges of the world too. All through Wyoming, you can show up to 45,000 feet of differential vertical tectonics where the mountains rose, the valley sank down, and it occurred in the Cenozoic. I have, check my website, Michael.ords, OARDS.net, I think. And you can see several chapters on all this stuff.
In order to buckle the rock strata to rapidly lift those mountains, you'd require catastrophic processes, the type associated with the flood, correct?
Oh, yeah. Yeah. To me, to think of those being post-flood, that's one of my 35 evidences of this tremendous uplift. And this is global, like this amount of uplift is one of my signatures of a flood signature, because you wouldn't expect that after the flood at all.
Right.
But during the flood, you would to drain the flood waters, according to Psalm 104:8. So yeah, and it practically all occurred in the Cenozoic. In fact, there are 2 geomorphologists, Cliff Ollier and Colin Payne, that wrote a book on the origin of mountains, published in 2000, and they republished information on the high mountains and when they when they uplifted, with table going through most of the mountain ranges of the world. That's published in a Russian journal. I think it's going to be a perspective article that's going to come out in the Journal of Creation down the road. It still hasn't been reviewed yet, or maybe it has been. I can't remember. But anyway, they list them, and they're all in the Cenozoic. A lot of them in the late Cenozoic. So wow. Indicating that you had powerful catastrophism during the Cenozoic.
Right. Therefore, if someone were to hold to a KPG boundary, a lower flood boundary, would they have to argue that your mountains started to uplift at the end of the flood, but rose higher and higher in the pre-flood world?
Not the pre-flood, you mean the post-flood?
Or the post-flood world?
Yeah, I guess so. But the main uplift and sinking of the adjacent valleys, it's very common to see adjacent to high mountains, valleys that go way down, like south of the Himalayas. You have the Ganges valleys, which represents, I'm estimating maybe 7,000 meters of sediment collected in there. So the Himalayas and the Tibetan Plateau went up, and the Ganges valleys went down, and then filled with sediments in the Ganges Valley. You see that theme all over, especially in the Rocky Mountains here. Yeah, this is all Cenozoic, and this would have to be practically all post-flood. Now, in some cases, it might have started in the Cretaceous, but practically all of it is post-flood, from the flood, and it's enormous worldwide. Again, one of my main criterion of 33 I developed, Tim Clary reinforced several I had already mentioned, already developed, plus a couple more. So about 35 total. And by the way, I think I can find more if I try, but I haven't really tried for 10 years. So I've gone on to other things like how to explain the strata that we do have. That's kind of what I'm thinking of now. So
that's very powerful evidence for a higher flood boundary, Mike. I appreciate those. Absolutely. All 35 of your criteria are, and the audience can see those in detail, of course, in your articles, but also in your 2 presentations with us.
Yes, in my presentations I've already done.
And so, okay, well, great responses. I can move to question 2, Mike, if you'd like.
Okay.
And okay, so question 2, basically, again, on the flood boundary issue, an important issue as we've conveyed. In the Cenozoic is how some lower flood boundary proponents would argue, specifically in North America. They say the dominant types of sediments look very terrestrial. They have entirely terrestrial organisms with no mixtures of marine organisms with them. And so they would argue that the lack of terrestrial organisms mixed with marine organisms is good evidence for a lower flood boundary, since they would say this isn't part of the flood itself. What's a good way to respond, or what are your thoughts, Mike?
Well, I look at the 35 criterion and say there must be an answer for the flood. But I believe we need to check the data first. I've heard that argument, and it's a good argument. In fact, at the International Conference on the Creationism, it was mentioned. So since I only had about 5 hours to think about it, I thought to myself, do I know any places in the Western U.S. where there's marine fossils in the Cenozoic? And the answer is yes. Okay, off the top of my head, there's Sharktooth Hill near Bakersfield, California, where I used to live. That's Middle Miocene, which is the very beginning of the late Cenozoic. Sharktooth Hill. How they all collected in that one area is a good question for future research. Like a lot of bone beds, there's hundreds of bone beds across the earth. I even have a book pretty thick on bone beds. Dinosaur bone beds are the most impressive, with thousands of individuals. So that's one area. That's in the southern San Joaquin Valley of California. Also, I showed you the Green River Formation. And this probably demonstrates why the issue of terrestrial versus marine, because the main criterion for determining whether strata is marine or terrestrial is the fossils. So if you find terrestrial fossils, it's automatically from a terrestrial environment, and vice versa for marine. But the Green River Formation, which is famous for its oil shale and its other fossils, has marine fossils in it. They're herring. And also there's a stingray. Now, since they believe it's overwhelmingly a terrestrial environment from a lake, they say these must be freshwater herring and a freshwater stingray, which is possible, but I'm not sure how probable it is. But regardless, they'd be marine fossils, but redefined as freshwater. So I'm thinking that maybe they're defining a lot of fossils they find that are marine as freshwater. Like they find shark teeth in various places like Sharktooth Hill near Bakersfield, California, in spots. And of course, they would explain it. So you got to explain that away in that, from their point of view, in that sharks came up rivers and died and their teeth are in terrestrial environments. Well, that can occur. In fact, has occurred. But I don't know whether you can really use that as good evidence. But so the upshot of this, I'm thinking that they defining a lot of or some fossils as terrestrial, and they really are marine. But I'll admit that the vast majority of the Cenozoic fossils are from a terrestrial environment. So that brings up further questions we can research. But I'm, excuse me, but I'm for looking at the data first to really see what we have there. I'm sometimes suspicious when they talk about all these freshwater mollusks versus marine mollusks. I don't know enough about it. My biologist friend maybe tell me, is there a real difference between the two that you can tell when you find a fossil of a mollusk? Or are they generally marine and they're just found in what they think is a terrestrial environment, so they're automatically called freshwater mollusks? So I don't know, but that's a problem. Another thing, now these are deposits and formations that I'm familiar with, that I'm mentioning. In the Palouse, I mentioned the Palouse silt. Now, the Palouse silt is about 100 feet thick, covering practically all of eastern Washington. It's very rich in that they farm on it, like the Palouse Hills of southeast Washington. But the secular scientists, you can find this in the old literature, reported you find sponge spicules in what's called the Palouse loess. Sponges are predominantly marine organisms, even though there's claims of, and there probably are freshwater sponges like Lake Baikal in southern Siberia, but I would think it'd be very rare. And by the way, these sponge spicules are not rare occurrences. I went around with the late Dr. Harold Coffin sampling the Palouse silt, and we found sponge spicules at about 25 locations in southeast Washington, everywhere. So it's not rare, it's common. So this could be, now it's interesting how to explain this, and I have attempted it in the past, but for this purposes, it looks like a marine organism, the skeleton of a marine organism within silt. So I don't think it's a loess, which is a windblown silt, except at the very top meter or so is obviously windblown. But being 100 feet thick, I believe most of it was formed during flood runoff, probably in a low slackwater area caused by the uplift of the Cascades. And that's when it dropped the fine silt layer, silt particles with the sponge spicules. Anyway, those are 3 locations. So I'm for checking the data first to see if that's correct. I'm only familiar with North America. If you go to other continents, you might find that's not true at all. You might find a lot of marine fossils in the Cenozoic and other continents, but I don't know. But I'll give it to them that the vast majority of them are from a terrestrial environment. And if it's from the flood, what is this telling us? The other 35 criterion would say from the flood, it seems like flood deposition was by environments. Whole environments were eroded and deposited with very few like for terrestrial environments, very few. And so the geological column goes from marine fossils up to terrestrial fossils. And this could easily be caused by vertical ecological zonation and even horizontal ecological zonation. People, creationists don't think about the horizontal, that we might have had whole different ecosystems. I'm not pronouncing it, ecosystems in one area, and you go maybe 5,000 kilometers in a different direction, you have a whole different type of ecosystem, and the flood buried them as different ecosystems. So that's kind of how I would respond. And anyway, I think I didn't have any slides on that. So
no, that's good.
My answer in 5 hours.
That's very good in 5 hours, Mike. You're a good critical thinker. There is someone in the chat that points out, and this might support what you're saying here. Maybe you have some thoughts. They say the very large Monterey Formation is marine and also in the Cenozoic.
Yes, because there's whale fossils, and it's late Cenozoic Miocene. There's whale fossils in the diatomaceous earth in the Monterey Formation. Yeah, that's another example. I didn't think of that. So that's the fourth example of this.
You mentioned. Oh, go ahead, Mike.
No, I'm done.
You mentioned the high point of the flood, if I remember correctly, was the KPG, with the receding phase comprising most of the tertiary. And so we'd expect basically what we see, like you were saying earlier, where you've got the receding phase after the high point of the flood. So it would look like the level or amount of intensity in terms of the catastrophism is being dialed down.
Yeah, it would probably through the Cenozoic, because it looks like the mountains rising started in the early Cenozoic and definitely concluded by the late end of the late Cenozoic, because during the Ice Age we didn't have hardly any vertical tectonics. Yeah, so, but this is exactly what you expect in the flood. It has to dial down.
Right.
So, and also the size of the formations have to decrease. But where the peak of the flood is in the geological column, I think we need to revisit that, because I believe that the Cenozoic in these mountain valleys where I live here in Montana, Southwest Montana, and Wyoming and other places, lost my train of thought suddenly.
No, that's okay, Mike. I wanted to ask one more question on this issue, and then Matt, I know you got some of your own questions too. And so I was curious, because you talked about erosion in your presentation. You've also given an entire presentation here on the receding phase of the flood. Mm-hmm. In terms of the flood boundary debate, what about the lack of erosion at the KPG? I'm wondering where are the canyons or the erosional remnants as the waters basically run off the continents at the end of the flood. Correct me if I'm wrong, we don't really see canyons formed until relatively recently. We don't really see canyons at the Cretaceous. It's pretty much flat, if I'm not mistaken. And so...
Yes, it's true. You're right. You'd expect all kinds of features in the Mesozoic, especially in the Cretaceous, that aren't there. Oh, I know what I was going to say. Where the peak of the flood is, I think the early Cenozoic in the Rocky Mountain valleys here is early flood strata. So the peak of the flood would include the early Cenozoic mainly. Why? Because the top of the Cenozoic in the mountain valleys has been eroded down several hundred to several thousand feet. The top of it's gone. It's been eroded, and that fits with the recessional stage. And so what's left would be from the early flood, especially when you have tracks in it, tracks of live mammals, and mammals have to be, you'd expect to be dead by the peak of the flood. So the strata, and I've written about this over the years, the strata in the high valleys, mountain valleys of the Rockies here, likely is from the early flood. So in this area, the peak of the flood would be up in the early Cenozoic. But the continental shelf strata is from runoff. And that Cenozoic would be from the late flood. But then in the ocean bottom, they claim there's ice rafted debris in the early Cenozoic. Now, this has to be checked out. I'm a little suspicious. But if it's true ice rafted debris, you had to have ice sheets, the Antarctic ice sheet and even the Greenland ice sheet in the early Cenozoic. And so that would mean a lot of ocean bottom sediments are post-flood. So the Cenozoic is what I call diachronous, formed at different times in the flood, post-flood, depending on the area of the world, from the high Rocky Mountain valleys to the continental shelf to the ocean bottom sediments. And I've written about that several times, and I think I'm going to write about it again coming out with more data. So the peak of the flood was variable in different areas, is what I'm saying.
Right.
I hope you clarified something.
You did, because especially for the audience, it's not like this strict line that we can draw on the line. Right. Yeah. It's a higher or late Cenozoic flood boundary, but variable.
Yes, variable for the flood, and I believe that every location has to be examined on its own merits.
Right.
Like the Australian marsupials, which I took a good look at, and I went along with Chad Arment's view that they're post-flood, and they're dated clear down to the late Oligocene, which is the very latest part of the early Cenozoic. But when I investigated this, I found out that they've been pushing them back, the fossils back, because of their stage of evolution and primitive features from the Pleistocene, which they first dated them, down to the Pliocene, Pleistocene, Miocene, and then the top of the Oligocene, based on just stage of evolution. They had hardly any radiometric dates in these isolated areas of Australia. That's published in the Journal of Creation, by the way, I might add, about 2 years ago or 3. It might be online by now. I don't know. They publish a lot of these online after a while. But if anybody in the audience that doesn't get the Journal of Creation and the Creation Research Society Quarterly, you should get it if you want some good new research on all these topics, including biology and astronomy, of course, and other topics that will appeal to other people.
Amen. Yeah. I've got a whole bunch of magazines behind me, endless reading, great articles. So since we hold to a late Cenozoic but variable flood boundary, Mike, I'm wondering, when it comes to the North American mammal challenge to those like us who hold to a higher flood boundary, could moving the boundary slightly higher in areas of apparent fossil overlap fix some of these challenges, since it is variable? Maybe in certain spots the boundary is supposed to be a little higher, where we find the overlap in these the mammal fossils.
I think that can explain a fair amount of it. Like I did a research project, published 2 articles on terraces in the upper Wind River Valley southeast of Yellowstone Park, and I determined that the pediments and planation surfaces, which are late flood runoff features, based on that, the ash from the last eruption of the Yellowstone supervolcano, the Lava Creek B ash, was found in the pediment gravel, indicating that all those eruptions were late in the flood and not post-flood, which had been a question I had for 25 years. But then as you go into the Midwest, where the Lava Creek B ash is located, it used to be it's a marker horizon. They dated about 640,000 years, something like that. And so that's how they date some of their mammals. But a lot of that covers up a lot of mammal areas. So I based that and other things that the Cenozoic mammals in the upper Midwest, in the southern and central upper plains like Nebraska, eastern Colorado, South Dakota, in there, that these mammals are from the flood. So you analyze them in deep cuts. There's a lot of them in the walls of those valleys. And if you interpolate between these, there's probably millions of mammal fossils buried in the top strata of the high plains, which is eroded down to this level, I might add. So the boundary there would cover up the flood post-flood boundary would probably be in the mid-Pleistocene. Pleistocene is no magic value for the Ice Age, by the way. There's strata a couple thousand meters thick in some basins that is labeled Pleistocene. So that's, to me, obviously not post-flood, but that's just a slot. So in some areas, the boundary could be in the early to mid-Pleistocene. And that would explain a lot of the mammals below that as being from the flood, and not putting a boundary down at the Pliocene, Pleistocene, where then you do have a lot of boundary crossing mammals in the Midwest and the plains. So I think I could solve that, but I need to write more about it and get into the pronghorn antelope example that Marcus Ross brings up, and he brought up again in the forum at the International Conference on Creationism. So I need to revisit that more. I've written 4 articles on it in the Journal of Creation already, trying to get into this, and I'm going to do it more this winter. But if I get around to it, I got so many projects this winter. But anyway, that's how you're right. By having a flexible boundary, we can explain some of these so-called boundary crossing genera.
Right. Well, that's a great response. Actually, great responses all around, Mike, to those questions. I could talk to you about flood boundaries all day. And so what I'll do, though, Matt, I know you had a couple of your own questions, and then we're going to get a few of these audience questions in, because we do want to wrap things up by 7 your time, Mike. So again, excellent responses to those questions and challenges.